Hey everyone, welcome to Build Your First Alexa Built-in Device. My name is Jeff Nunn. I'm a Senior Solutions Architect here on Amazon Alexa. And with me today, I've got my buddy Eric Faisal. So Eric is with Alexa Voice Services. And today we're going to show you how to turn any device into an Alexa device. We'll do that a few ways. One, I want to cover basically what type of devices there are for Alexa. I'll talk about some categories like smart home categories. We'll talk about what it means to be Alexa built-in versus works with Alexa. We will also show you a hands-on demo on how you can make any device into Alexa. Today, if you're following along at home, you don't have to have special hardware to follow along in this session. I'll give you links at the end if you do have hardware like a Raspberry Pi or microphones or little LEDs. But today, all you'll need is a laptop or a computer, and Eric's going to walk through and show you how to follow a GitHub repo and turn your computer into an Alexa device, which is pretty cool. At the end, we'll wrap all that up. We will talk about ways to get started. I'll provide some links to the GitHub repo and a few other samples. So let's get started. At Amazon, our vision is for Alexa to be available everywhere our customers want it. And that might mean available at home, it might be available on the go, or even available at work. So at home, for example, I use Alexa all the time. I'm sure you do too. I use Alexa to turn on my lights, to lock doors, to shut my garage door. On the go, I use the Echo Buds. These are Alexa-enabled earbuds that I can use to plug in to tell Alexa to skip to the next song, or skip ahead 30 seconds, or skip to the next chapter, turn up or turn down the volume, etc. What I really like about the Buds is if I'm running and I take one out, if I see someone I know, I can take one out, it'll pause, I can talk to them, we can have a conversation at a safe distance, and then put it back in. And then as soon as I put it in, these sensors, these light sensors, let it know that it's ready to play again and automatically plays. But I've got access to Alexa through those Buds, so anything I want to do as far as setting a reminder I can do. I can ask it for weather for the location I'm at. It's great, so that's Alexa on the go. And finally, Alexa at work. So Alexa at work we use all the time. Back when we were meeting in the office, we could say, Alexa, start my meeting, or Alexa, set our calendar reminder, Alexa, maybe order some new supplies, but Alexa everywhere. So our goal is for Alexa to be available wherever you want it. Now look at the screen here. On this screen there are a lot of devices. I've been here for about 6 years, and that's before Alexa started. When I first started, it was one device. It was the Echo, the original Echo, and it was that tower-looking one. You probably remember the black tower with a spin dial on top. There's a nice blue ring behind it. And that Alexa was the first smart speaker. It really ushered in the era of smart speakers. But these devices on the screen behind you, or behind me, are all devices that are produced by Samsung, LG. You've got set-top boxes that you can use to control Alexa. So you can say, Alexa, change the channel, or Alexa, switch to Netflix, Alexa, play something from Prime Video, or volume up. A lot of options you can do just through voice, and that's really what we want. Voice is simple. Let's make the interaction between voice and hardware just as simple. Another category you might not think of as often are just devices with screens. These are devices that can have Alexa built in. So if you have a Windows 10 device right now, maybe it's a laptop or desktop, you can go to the Microsoft Store, you can type in Alexa, you can install Alexa for free right now on your laptop or your desktop. Lenovo has a really cool smart tablet, so you can walk around with the tablet, interact with Alexa on it. When you want to plug it into the dock, it will give you rich, full, immersive sound. And I think that's really cool too. It's kind of an Alexa at home plus an Alexa on the go if you want it. And then finally, the Facebook portal. Some of you may have the portal. Portal is really cool because you can access two different AIs. You have the Portal AI that you can talk to, the assistant from Facebook, and you have the Alexa assistant built into that same device. Now this category, smart speakers, is a great one to have around the house. So you can have Sonos built-in Alexa speakers. These are speakers that you can hang. Imagine one hanging over your deck in the backyard. You're having a party with friends. Maybe you want to change the playlist. So you talk to the speaker and say, Alexa, switch my playlist to summer hits, and it will play your summer hits playlist. I also like the Polk soundbar you see there. That Polk soundbar puts out a full, rich, immersive sound. It's great for home theaters. Another favorite, one I don't have yet, but it's on my list, is that Marshall amp you see. And that looks like a Marshall amp, but it's a speaker designed to look like their iconic amps, and it has a beautiful sound to match the beautiful look. So one thing I want to mention too is routines. Routines are actions you can set up from within the Alexa app, and you can connect your smart home devices through these routines. So imagine this scenario, and this is what I have set up at the house right now. But I can say, Alexa, good night. And Alexa will automatically lock my front door. It will make sure my garage door is shut. And it will dim all of my hallway lights, but turn off all of the other lights. So we've got lights in the hallway if anyone needs them in the middle of the night. All the other lights go off. But it is a way to connect all my smart home devices together. And I can add more and more if I wanted, but you can create multiple routines. So if you haven't tried that yet, try routines. I think you'll enjoy the flexibility they give you. So I want to talk about the 3 different paths now that you have as a developer. There are 3 broad categories you can think about when you're building your product. There are 3 main categories that you should think about as far as how you want your device to sit. The first category are Alexa built-in devices. Now these are devices with one or more microphones, a speaker, and some sort of processing. So you've got a microphone that listens for input, you've got a speaker that can give a response, you've got processing that listens for the wake word. Now the wake word, as you probably know, can be Alexa, or computer, or Amazon, or Echo. So it listens for the wake word, receives the request, processes it, and sends it off. And in a few moments you're going to see Eric, my colleague, do a demo with that on his laptop, and it's a demo you can follow along with and do the same thing. So this is an Alexa built-in device. The second category is a pretty broad category. These are devices that work with Alexa. A very common example is a light bulb. A light bulb works with Alexa, but doesn't need a microphone, it doesn't need speakers. Maybe it's a thermostat. You can have a thermostat with a mic if you want, but in most cases you're going to find smart thermostats that are controlled by Alexa, but don't necessarily need all that processing and microphones and speakers built in. So these are great if you want to have components that don't have a lot of other parts to them. You really just have a light bulb and some small processing in there that listens for commands and can turn on and off. The third category is something that you can do without any hardware at all, and those are Alexa skills. I'm assuming since you're at this conference you know about skills, but you may not have built your first one yet. So if you're watching this conference, there are sessions on building a skill, or if you already have a skill, making the skill better, or a third category of using that skill to earn money through our in-skill purchases program. So skills are very simple to get started. If you want to go to our developer.amazon.com, you'll see we have templates to get started. A template might be a simple quiz skill like quizzing on geography or presidents or types of foods or animals. Very simple skills to build, all the way to the other spectrum with really neat, complex, immersive, rich, interactive skills with touchscreen games and devices that can show you your smart home products, cameras, and allow you to change settings just on the screen. So a lot of options when it comes to building skills. But those are the 3 main categories that you'll think about when building something with Alexa. Okay, before we get to the demo, let's talk about a few numbers, because these numbers are mind-boggling. I've told you I've been here since Alexa started. I've seen these grow from literally 0 to where they are now. From 0 to 100,000 plus smart home devices. That's a lot. From 0 to 9,500 plus unique brands. These are companies that are building really cool products, and I'd love to add you to that list too. And then 11,000 plus certified devices. Certification we'll talk about, and I'll leave a link for you at the end of this. But certification gives you a way to validate that you've built a really good product that adheres to our standards. We go through and check everything off. You get the certification badge that you can put on your product, so when people see it in stores or online, you've already established the trust that this will work with Alexa. And the reason we're seeing these numbers go up so high is because voice is simple. Voice lets you control hardware by just saying things like turn on or turn off, or switch, or order pizza, or order a car from Uber, or play games on Jeopardy. Things that used to be very hard or take multiple steps or a lot of interactions are now very simple with voice. So with that, I'd like to turn it over to my partner, Eric Faisal. Eric works for the Alexa Voice Services team, and he's going to show you how to build Alexa into a device. When he's done, I'll come back, I'll leave you some getting started guides, and we'll go from there.
Yeah, thanks, Jeff. I'm Eric Faisal, a solutions architect for the Alexa Voice Service. My group helps device makers such as LG, Bose, Sonos, and others add software that turns their devices into Alexa built-in devices. So I want to talk a little bit more about how these Alexa built-in devices work. So anytime you speak to a device, whether it's an Amazon Echo, Harman Kardon speaker like this, LG TV, they all function about the same way. First, it starts with you speaking to the device. So the device is going to take that audio through a microphone. It's going to stream it to the Alexa service. The first step is called automatic speech recognition, or ASR. So it's going to take the syllables, the noises that are coming out of my mouth, and it's going to translate that into text. Next, it's going to go through what's called natural language understanding, or NLU for short. It's going to take that text and determine what is the customer trying to do. In this case, we're asking about weather, more specifically rain, and for a date of tomorrow. Next, it's going to go to a skill to try to fulfill that intent, to try to understand how to get the answer or to do the command that the customer is asking. In this case, it's going to look up a weather skill and retrieve weather information for that location and date specified by the customer. And then finally, because as part of that response, if it just came back with the answer of no or 25%, that's not really helpful. So that's where TTS, or text-to-speech, comes into play, where it's going to take that answer and make it into a human-friendly response. Now, if you have a smart home device and you want to control it with your voice, it's going to function about the same way. So it's going to go through that same speech recognition, natural language understanding, and skill handoff. In this case, that skill may be, in this case, a Philips Hue skill, where it will then issue a command through that device cloud to control the device. Now, there's one other pattern. What if your device has both a microphone and a speaker, and you can control it through your mobile app, etc.? Well, you can have that device cloud send information straight back to the device. And there's finally one more pattern where we've actually simplified the process a bit, such that if you want to be able to control that device, you can actually do that just through the Alexa voice service without actually having to go through a separate IoT or device cloud. So when we talk about what's in an actual device, you want to make it Alexa built in. What do you have to do? Well, first, you're obviously going to need a microphone, but you're also going to have to figure out how the customer is going to signal that they want to speak to Alexa. So there's generally two modes. One is you can push or tap a button or hold the button, etc. And then once you do that, that signals the customer intent to talk to Alexa. Or what probably most of us are more familiar with are the hands-free or far-field audio scenario, where you say Alexa, and then the next utterance is going to go to Alexa. I mentioned microphones. You need to figure out how many you need. One, multiple. Now, if you were using, say, that remote, and you're only a couple inches away from the microphone, one microphone is more than enough. It's fine. But if you want to be able to speak to your device from across the room, then you probably might need two, at least two. Some devices have 4 or even 8. And you're also going to want some noise reduction algorithms. For those microphones, you need to figure out where you're going to place them. For something like an Echo Dot or an Amazon Echo, it's circular because it can accept audio in all different directions. But if your device has a screen, more than likely your customer is going to be talking to the device from in front or next to the screen, probably not behind, so just something like a linear array is going to be just fine. So let's talk about the wake word engine. The wake word engine is actually software running on the device that's always listening just for the keyword, in this case Alexa. In a way, it's kind of like, my name is Eric. I'm always listening if somebody says Eric from around. And once I hear that, my ears perk up and I try to figure out, who's talking to me. The wake word engine is similar, and it's trained to listen to those consonants or phonemes of Alexa. And then once that happens, it then triggers a command to start recording the audio as it signals the customer intent to talk to Alexa. When the device talks to Alexa, it's through two things, events and directives. Now these are both JSON, and events is communication from your device out to Alexa. Directives are information or commands coming from Alexa back down to your device. We're going to dig into these a little bit, but ultimately, all you need for an Alexa built-in device is to be able to handle events and directives. So let's talk through an example that seems simple. Setting a timer, do it all the time, especially in the kitchen, right? So seems pretty simple, 10 minutes starting now, but behind the scenes, there's actually a bit more going on. So in addition to just simply saying that the timer has started, the device is actually going to set the timer in a local data store on the device. That way, in case the device loses internet connection, the timer still goes off. We don't burn our bread in the oven, etc., right? But also, there's a variety of communication going back and forth between device and the service, saying that the alarm was set, is succeeded, when the alarm goes off, etc. So it's actually quite a bit more complicated than it seems, especially for some of these scenarios. So let's talk a little bit how you can add software to your device so that you can turn it into an Alexa built-in one. And with that, we're going to talk about 3 different SDKs we have available. The first one is the AVS Device SDK. It is the basic functionality you need to turn your device into an Alexa built-in, plus it's modular so you can swap out components, and it's really where we recommend our starting point for any device maker. Next is the Smart Screen SDK, which extends that device SDK that adds visuals, visual support, visual displays, and also allows for touch or select input on the device. And our third is AVS Integration for AWS IoT Core. This is intended for low-power devices, and it actually uses an MQTT connection to AWS IoT versus the standard HTTP2 connection to AVS, and offload some of those resources to the cloud. We'll talk about that in a bit. So if you're wondering, well, what's the difference between these 3, aside from what I just mentioned, some of the key components are the type of devices that they're best suited for. Like I said, the AVS Device SDK, it's well suited for something like a smart speaker, perhaps a wearable as well. The Smart Screen SDK, that's going to be best for your TVs, set-top boxes, and smart speakers. And finally, AVS for AWS IoT Core is really intended for something like a light switch, thermometer, or appliance. The other piece I want to call out is on that row here for speakers. So you'll notice that the first 2 SDKs I mentioned, they're optimized for both speech and music playback, whereas AVS for AWS IoT Core is really optimized for speech playback. We probably don't expect too many people to be listening to a ton of music on their light switches or thermostats. It does happen, it can support it, but it's just not necessarily optimized for it. So with the Device SDK, first of all, it's for free. It's free, available on GitHub. You can download it. I'll be walking you through that a little bit later in this presentation. It does support voice interaction, basic music support, alerts, alarms, and notifications, a network connection, multi-room music, Bluetooth management, and more. So absolutely recommend you start with this. There's more information on the GitHub page, along with documentation on the different Alexa APIs and all the different components. Let's pivot a bit now and talk about the Alexa presentation language. This is the common design language used across all Alexa devices to render visual content. It uses flexible layouts and renders appropriately for the device size and shape. It supports things like weather, music, jokes, lists, and thousands of skills written by developers. The Smart Screen SDK renders APL on the devices. So in addition to needing the AVS Device SDK, the Smart Screen SDK also is composed of the APL core and also an APL view host that's going to render the visuals. This also is another GitHub page for the Smart Screen SDK, so you can download it, you can run it yourself. I'll be showing you that in a minute. And on the page, you'll see a variety of the components listed. And you can find this in real life on LG and many Samsung TVs to have these rich Alexa visuals. And again, our third and final SDK is the AVS Integration for AWS IoT Core. And the main benefit, again, is that it uses an MQTT connection to AWS IoT and to offload some of those high-intensive computational tasks to the cloud. So the real benefit is that it really reduces the hardware required to be able to turn your device into an Alexa built-in device. You can actually run this on less than a meg of RAM. So this enables more devices to become Alexa built-in devices. So I've got the chart up here that we've shown from before, and some of the key questions you need to ask yourself when you're deciding which of these SDKs should I start with is, what's your processor and RAM available? Do you have a screen? In general, we do recommend the Device SDK as the starting point for most device makers. It is by far the most robust and featured solution, but if your device has a screen, that's where we obviously recommend you look into the Smart Screen SDK for both the visual output as well as supporting touch inputs. But if your device has limited hardware capabilities, limited RAM, resources, etc., that's really where AVS for AWS IoT Core comes into play. So next, I'm going to walk you through the first of the two SDKs I mentioned and talk a little bit about how you can get hands-on yourself.
So first, let's take a look at the GitHub page. So mention github.com/alexa/avs-device-SDK. A little bit of a mouthful to say, easier to type in and see. But once you open up the repository, you'll see a variety of folders on here. So as mentioned, the various components are modular. You can modify the code. You can swap out different components based off of what you need. And then you'll see some overview information. Additionally, you'll see a variety of these getting started guides. If I were to open up Raspberry Pi, it's actually going to detail the different equipment you need, the hardware, microphone, etc. Alternative, you can also do it on a Mac OS, Windows, Linux, Ubuntu Linux computer. There's a variety, so I'm using my Mac here. And ultimately, once you get everything running, you're going to do much of this on the terminal or the command line. So I've already downloaded the code, I built it, and now I'm ready to run. So there's a couple things you'll need. So I've got my launch command here. So what I'm going to do is first part is just stating the sample app. So as part of the SDK, it comes included with the sample app, and this is what we're running. This is the actual client that's going to be running on device that is going to be able to communicate with Alexa. There's a configuration file I have here that I where I have to find things like my device serial number. It's also got references to my local data store, etc. And then finally, that last bit, info, is the logging threshold level. There's a variety of levels. Info is good for something like this, where it's not too verbose. You can get as deep as something called debug 9. So once you launch the sample app, you're going to see a gorgeous UI. It's going to tell you the version of the SDK, and it's going to give you a variety of options. For instance, how to use this device, how to bring up the settings, how you can emulate playback controls for music, etc. So generally, when you first start, you can hit the key T, you can hit enter, and then you can say your question. So I can T enter. What is the tallest point on Earth?
The tallest headland is Mount Everest.
Yep, I thought it was. So there's some other things going on here. So you notice I've called out the directives and events. As I said before, events are the information going from your client to the service, and directives are commands or information coming back from the service back to your device. So the main one here is the speech recognize or not recognize for audio going out to the service, and the main directive coming back is generally going to be this speech synthesizer.speak. Now, because I'm only running this in info mode, it's not actually printing out the full JSON, but certainly if you run it in a debug logging threshold, it'll be more verbose. You can see the actual full JSON of information going to and from the device. So let's do another example. Now, In that case, I use T as tap to talk. I've also run this with a wake word, so I can do something like, Alexa, set a timer.
Timer for how long?
5 seconds.
5 seconds. Starting now.
So notice how the microphone opened up automatically after, as part of the question. It's called a multi-turn dialogue. Alexa, stop. Also recall that in my flow diagram where I said that setting a timer seems simple, but there's actually a lot going on back and forth. Notice all those events and directives going back and forth. The only other thing I would call out is that when the timer went off, it actually initiated from the device as an event out to the service saying, hey, the alarm went off. So even if I were to disconnect my internet, my alarm would go off, fortunately. So that's the regular SDK. Now let's take a look at the Smart Screen SDK. So Smart Screen SDK is another repository. So we shared the link earlier. And this extends that device SDK, also has the APL core library and a view host for your UI client. So on the GitHub page, you'll find more information about the various components, etc. The main thing you might be interested in is perhaps the quick start guide. You'll see a lot of similarities with the regular AVS Device SDK. A lot of it will have the same dependencies, and in fact, if you've done the Device SDK setup recently, then you can almost skip straight to step 6, as you will already have a device, you'll already be authenticated, authorized, etc. There is one subtlety in how you build the Device SDK so that the Smart Screen SDK can make use of it. But ultimately, once you build it, let's jump to my command here. So we're going to be launching a different sample app than our regular Device SDK. We're going to use that same configuration file, so it's going to have all my same previous device settings like serial number, language, etc. But there's also a new configuration file for the Smart Screen SDK, and again, you can specify what logging threshold you use. But you also need to have a web browser. So in this case, I believe we actually are connected, and again, so I'm using wake word. So I can do something, again, like, Alexa, how tall is Mount Everest?
Mount Everest is 29,029 feet above sea level.
Awesome. So we still have our same events and directives, but in this case, it can take the directives and actually use that to render content on screen. And as we saw, this is a partial panel. It rolled up from the bottom. If we use more of the smart screen profile, it would be occupying the full screen. So another thing I can do is, Alexa, what's on my shopping list?
You have 3 items on your shopping list: eggs, bread, and milk.
Yep, seems about right. So those are both partial panel, but what if I want full screen? Well, things like music, custom skills, and even something like, Alexa, tell me a joke.
What's an avocado's favorite arcade game? Whack-a-mole.
Yes, Alexa is an excellent joke teller. Oh, sorry. But the other thing that I wanted to emphasize is that, so this display is using the Alexa presentation language, and it was able to synchronize the scroll of the text along with the voice. If we displayed the entire text at the beginning, we'd literally be showing the punchline of the joke before it was actually shown, and by waiting until we were actually on the second part of the joke to display it, it improves the experience. So I think APL gives functionality like that along with others. With that, I'm going to hand it off to Jeff Nunn to tell you how you can get started on your own device.
Okay, cool. Thanks, Eric. I hope through that demo you saw how easy it was to build Alexa into your own device. So how can you get started? Well, it's pretty simple. I'm going to put the GitHub link that Eric used on the screen right now. So this GitHub link will take you, it'll show you exactly how you need to get started. It'll give you the step-by-step instructions. And of course, if you need help, there are ways to reach out to us, and we will be happy to help you. Now on this screen, you see a lot of big names from big companies that make amazing products that work with Alexa or have Alexa built in. What I want to emphasize here is these companies have access to the exact same documentation, SDKs, and tooling that you do. If you want to go out and start building this yourself and building the next new smart home product, you have the ability to. So hopefully through these links, you'll start seeing that, oh, I have the same access to the same tutorials, the same reference kits, and everything else I need to get started. Okay, so maybe you've been watching this and you like the idea of smart home products, you like the idea of building your own, but you don't have the expertise. Maybe you don't know how to code, maybe you don't know how to do hardware. These are common things, but you have great ideas, so you need to get those ideas built into a product. The site you see here is a site you should visit. This will give you some systems integrators, some partners that can go through and help you from start to finish. And there are a few paths here. One would be you can start with a development kit, and these are pre-built kits, a little similar to the Alexa Connect kit, but some of these are really robust. So some come with an entire microphone array of microphones that you can attach to products. Some are full products that you can take and start tweaking them and changing functionality to build your product, or at least to prototype it and get it ready to build. If that doesn't work for you, if you don't want to mess with hardware, you just want to talk to someone to build your products, then think about talking to our ODMs. So original device manufacturers can help you through all the stages. So stages of building your product, going through and finding the right vendors, helping you select the right stack. ODMs will have pre-built solutions for you that you can start with or you can look at and get started. And the last would be professional services and consultants that can help you from start to finish. And I mean start to finish. So how do you market your device? How do you set up your supply chain? How do you forecast sales? This would be a complete end-to-end solution that you can talk to someone to take your idea and make it reality. Well, on behalf of Eric, myself, I hope you enjoyed this session. I hope you learned a lot, but I hope more than anything that you had a good time and that you see how to build something you've been thinking about for a long time. If you need any help, if you have any questions, you can reach out to me at Twitter, JBNunn, or Eric at Eric Faisal.